Section 2.4, number 68. Here we are given a quadratic equation and we're asked to solve this thing for x, whatever way is convenient. Okay? It shouldn't matter which method we use because the method, the result should be independent of the method. So I'm going to do a couple of these. Right? The first one that I can see is that this is a square minus another square is equal to 0. So I can add this thing to the other side and then take square roots. So if I add b to both sides, right, b squared to both sides, that's going to cancel, leaving a squared, x squared is equal to b squared. And then if I take the square root, recognizing that I will have to allow for both the positive and the negative, this is going to give me ax is equal to positive or negative b. And then if I divide both sides by a, I'm going to have that cancel. So x is going to be b over a is one solution, the positive one, or x is going to be equal to negative b over a. All right, so that's recognizing the fact that we can extract these square roots. Now, another way we can see is that this is a difference of squares. Differences of squares can be factored in terms of ax plus b and ax minus b. Okay? But because this times this is a squared x squared, this times this is minus abx, this times this is plus abx. So we're going to minus abx plus abx, so that term will cancel. B times negative b is negative b times b, which is negative b squared. So in this case, either ax plus b is equal to 0, which we subtract the b to the other side, ax is equal to minus b, divide both sides by a, you're going to get x is equal to minus b over a is one solution. Or this thing is equal to 0. Ax minus b is equal to 0, which we can add b to both sides. It'll cancel here, become a positive b here. Divide both sides by a, it'll cancel there, becoming a b over a. X is equal to positive b over a. So those are the exact same things we got last time. Now the other way of doing it is doing it in the quadratic equation. Now bear in mind the a's and b's that we used in the quadratic equation are not the things that we use, are not the same a's and b's we have here, right? It's whatever we have here, we don't have a middle term, right? So we're going to have a squared x squared plus 0x plus a minus b squared is equal to 0. So x is going to be negative the term that multiplies our linear bit, so that's 0, plus or minus the square root of the thing that multiplies our linear bit squared, minus 4 times whatever is in front of our x squared term, times whatever is in front of our, whatever is our constant term, over 2 times whatever is in our square term. Okay? Now, if we keep track of our zeros, right, well, that's a 0, so we don't care about that. This is plus or minus. This is minus and a minus is a plus. So we're going to get the square root of 4a squared b squared over 2a squared. But this is a square root of a whole bunch of squares. Square root of 4 is 2, square root of a is a, square root of b is b. So this is going to be plus or minus 2ab over 2a squared. Okay? Now, we don't have any additions and subtractions. That's a 0. So there's no additions and subtractions here. We just have the positive possibility and the negative possibility. So multiplication and division play nice. So this 2 will cancel out with that 2. This a will cancel out with one of these a's on the bottom. So our options are plus b over a or minus b over a, which is again exactly what we got the last time around. So the method shouldn't change the results, one of the truths in mathematics.